Hi everyone.
Good afternoon, ma'am. Good evening.
Yeah, good evening. Yeah, so this is your week 8 doubt session. So you can start asking your doubts.
Ma'am, I have a doubt in the activity 8.4 last question.
Okay, okay, activity 8.4. Third question, right?
Yes, ma'am. Here we have to use that moment expansion formula, but I don't know how to properly use it.
See, you have to use that distribution thing here. You have studied gamma distribution here in week 8. So you have to use that property and then you can directly find the variance of this squared of these random variables. Okay, so we are given that x1, x2, x3, x4 are IID normal 0, comma 4. And we have to find the variance of the sum of square of these random variables x1 to x4. Okay, so if you have seen the lectures, you would have seen that the square of normal distribution, okay, it is following gamma distribution. So the thing is that square of normal 0, comma sigma square. Okay, so this is gamma with parameter 1 by 2 comma 1 by 2 sigma square. Okay, so generally we represent that gamma distribution with parameter alpha comma beta, right? So here alpha is 1 by 2 and beta is 1 by 2 square, sorry, 1 by 2 sigma square.
Yes,
Okay,
ma'am.
and we know the mean and variance of gamma distribution, okay, with parameter alpha comma beta. So for gamma alpha comma beta distribution, the mean is equal to alpha upon beta, and the variance, that is equal to alpha by beta square. Okay, this is the general formula for gamma distribution. Now here we have a particular case of gamma distribution. Okay, so here value of alpha is 1 by 2. So for gamma 1 by 2 comma 1 by 2 sigma square. Okay, so
Okay,
here
ma'am.
alpha is 1 by 2 and the value of beta will be 1 by 2 sigma square. Okay, now we can calculate the mean for this distribution. Okay,
Yes, ma'am.
so mean will be 1 by 2 divided by 1 by 2 sigma square.
Yes, ma'am.
Okay, so ultimately this value will be sigma square, right?
Yes, yes, ma'am.
And the variance is alpha by beta square. Okay, so alpha, which is 1 by 2, and beta is 1 by 2 sigma square and whole square of it. So it will become 2 sigma to the power 4, right?
Or
Okay,
yes, ma'am.
so this is the variance for suppose we have a xi. okay, which is following this distribution. So the variance for xi is this. Now in the question, we have four distributions.
Okay,
Sorry,
ma'am.
not distribution, for a random variable. Okay, so
Yes, ma'am.
uh, so I can write it like xi square. Okay, and x is following normal distribution with 0 comma sigma square, suppose. Okay, so in general I can say that if x is following, xi is following normal 0 comma sigma square, then xi square will follow this distribution. Okay, now these all are IID. Okay, so the variance of xi is x1 square plus x2 square plus x3 square plus x4 square. So we'll add the variance of these four random variables. Okay, so simply it will be variance of x1 square plus variance of x2 square plus variance of x3 square plus variance of x4 square. Okay, now we know the variance for these random variables. This will be 2 sigma square, sorry, 2 sigma to the power 4.
4.
Okay, so 2 sigma to the power 4, and this is for all the four variables, so
4
we have to
variables.
add it 4 times. So it will be 4 multiplied by 2 sigma to the power 4. So 4 into 2 into, now in the question it is normal 0 comma 4. So value of sigma square is,
4. Sigma
sigma
square.
square
4
is
to the
4. So it will
yes.
be 4 square 16.
Yes, ma'am.
Right? Now you can
Got it.
calculate.
Yes, ma'am. 128.
Yeah, so you can check answer. It should be 128. Okay. Is any other question from other activities? 8.1.
Question number 6 from practice assignment.
Okay, practice assignment. Okay, solution will be given, I think, for it already.
No, ma'am, for practice assignment it is not given for week 8.
Oh, it's not uploaded. Okay. This question, right?
Yes, ma'am.
So here we are given four random variables x1, x2 up to x4, which is following Poisson with parameter 4. So what should be the value of n such uh, that x bar is falling between 3.8 to 4.2, and this is greater than equal to 0.95. So we have to find the value of n. Okay.
Yes, ma'am.
Okay. So this is following this distribution, and we are given that x bar, it is falling between 3.8 to 4.2. Okay, this is given to us. Now if I consider that s is some variable, okay, which is the summation of these x1, x2 up to xn, right? We are given n variables here. Okay, now we know this thing that s minus n mu divided by root n sigma. Okay, this will follow normal 0 comma 1, right?
Yes, ma'am.
Okay, so n is something that we have to find here. Okay, and mu and sigma we can calculate. So what will be the value of mu? So mu should be 4, because you can see it is following this x1, x2 are following Poisson distribution with variable with parameter 4. Okay, so this is the value of lambda. And what is the mean for Poisson distribution with parameter lambda?
Standard deviation is 2.
Yeah, I'm asking what will be the mean.
For what?
Yeah. What is, if you have a distribution Poisson lambda, what is the mean for Poisson lambda?
The
Lambda.
lambda.
Lambda only, right? And the variance is also lambda.
Lambda.
Same. Okay. So mu will be 4, and sigma square will also be 4, which implies that sigma will be 2. Okay. Now we have to use this thing here. Okay. So probability 3.8. This is x bar. This is greater than or equal to 0.95, right? Yeah. Now x bar we can write it is equal to x plus x1 plus x2 up to xn divided by n, right? We can write it like this.
Yes, ma'am.
Now we will this summation we have written it as s. Okay, so we can write it as s. So s by n. Now we got this. Now our objective is to convert it like standard normal. Okay, so we have to make it like this: s minus n mu divided by root n sigma. Okay, so we can write that s minus n mu, okay, divided by n we already have. Okay, so I'll do it like this. You can transfer n to both sides. Okay, we'll do simple calculation. Okay, 4.2 n. Okay, I have just transferred the n to both of the sides. Now you can write this will be 3.8 n. Okay, now we have s. We will subtract this n. Okay, first we will subtract this n mu. So that we will have to do at both the sides, right? Okay, this is greater than or equal to 0.95. Okay, I hope it's clear to everyone till this point.
Yes, ma'am.
Okay, now this is 3.8 n minus n mu. Now we can divide by root n sigma. Okay, we have to divide by this quantity, root n sigma. Okay, so this is greater than or equal to 0.95. Now this quantity, okay, this will become z. Okay, this is standard normal variate, and we have to solve these values, and we can put the values of uh, mu and sigma here. Okay, so this is 3.8 n. Okay, so we can take n common here. If you take n common, it will be 3.8 minus what is the value of mu? So mu is equal to 4, right?
Yes.
This is 4 divided by root n, and value of sigma is 2. Okay, we just have to put the values. Here also n is common, then 4.2 minus 4 divided by root n, and value of sigma is 2. Okay, yeah, so calculate this part. So this will become root n. What will be this value?
Ma'am, minus 0.2.
And after dividing, we have to divide by 2 also. So this will become 0.1 negative, right? Calculate the second one also.
Ma'am, that is plus root n 0.1.
Yeah, so this will be the same quantity but in the positive sign. Okay. Okay. Now we can write it in the form of CDF of standard normal, right? So this will be Fz at 0.1 root n minus Fz at minus 0.1 root n, right? Is this clear to everyone?
Yes, ma'am.
Now this has negative sign, so we can write it like this. So it is 1 minus Fz of 0.1 root n. Okay, and this entire is greater than equal to 0.95. So now if you open this bracket, this will become 2 times of Fz 0.1 root n minus 1, and this is greater than or equal to 0.95. Okay, now from here, what will be the value of this?
1.95.
Yeah, 1.95. Then we have to divide by 2, right? So this will become 0.975. Okay, now you can see in the question we are given this value. So 0.975, okay, this is equal to Fz 1.96. So Fz 1.96, this is equal to 0.975. Okay, now we can put this value here. So this will become Fz 0.1 root n greater than or equal to, at the place of 0.975 we will write this value Fz 1.96. Okay, now you can compare these two. So 0.1 root n, that should be greater than or equal to 1.96. So root n is greater than or equal to 1.96 divided by 0.1. Okay, now we just have to square this value. Okay, so n will be greater than or equal to 19.6 whole square, right? Now calculate it.
Yes, ma'am.
384.16. Okay, so now you can see 385 will be satisfying this criteria, right? So n is greater than or equal to 384.16, which means n should be an integer value. Okay, so it should be, n should be greater than 385. Oh, sorry, like at least. Okay, greater than, which means at least n should be equal to 385. Okay,
Yes, ma'am.
the next integer value to 384.16 will be 385. So you can see option B will be correct. Okay. Is any other question?
No, ma'am, not now.
From 8.1, anyone else? Yes, anyone has a doubt?
Ma'am, 8.2, the data given is not there in the sheet. What is the data given? I could not understand.
Which question?
No, for all the questions, the reference data given, I could not understand.
Where it is written that reference data?
Use the following data just on the top.
See, this is written that use the following standard normal distribution. So these values are given which you have to use in the calculation. Okay, not the data.
Yeah, but what are the values? Okay,
Yeah,
complete.
this is given. FZ at 0.2617 is 0.603. So
Okay,
when you will be
question number two, I could not do.
okay. So question number 2 is the random variable x is representing the number of cherries in a cherry puff has the following probability distribution. Then find the probability that the average number of cherries in 64 cherry puffs will be less than 7. So did you try to solve this question?
Yes, ma'am, I got a mean 7. Then after that, how to proceed?
First of all, we are given the distribution of x.
Finding the variance.
So we, whenever you are solving these type of question, you should know the mean and standard deviation of that variable,
So mean
right?
we can find using this PMF.
Yeah. So
So x
PMF
times
is
px.
yeah PMF is given. You just have to use the formula of expectation of x, which is summation of x into probability of x. So from there, you can calculate the value of expectation of x. Similarly, if we need to calculate variance, we need to calculate the expectation of x square, right? And then we can find the variance by using the formula that expectation of x square minus expectation of x whole square. So we have to use this PMF. Okay, so calculate the value of expectation first. What it will be?
7.
7. Is it for same? Is it same for everyone? 7 is correct or not?
Yes, ma'am.
Okay, so expectation of x is 7. The probability we have to find is that average number of cherries in 64 cherry puffs will be less than 7. So that average number, okay, in 64, which means the sample size is given, which is 64. So this average value should be less than 7. This is something we have to calculate, right? So x bar is given, so we have to subtract its mean and divide by standard deviation. Or you can convert this x bar into like summation and then divide by n and then transfer this n to both of the side and then subtract the mean of this s and divide by the standard deviation of s. So you can use any of the methods. So expectation of x, okay, we represent it as mu, which is 7. Okay, so you can see that this is also 7. This value is also 7. Okay, so that does not matter. So we have to find, suppose the variance of x is sigma square. Okay, so standard deviation will be sigma. So you can see that when you subtract the mean, which is 7, okay, and divide by the standard deviation. So standard deviation of x bar. So that is sigma by root n, right? If you remember.
Yes, ma'am.
I'm writing here no. Okay. So this is 7 by 7. Oh, sorry, 7 minus 7. So you don't need to calculate the value of sigma because ultimately it is going to be 0. Right? Is this thing clear to everyone?
Yes, ma'am.
Okay. So this value, this quantity has become a standard normal variable, which is z. And then this value will be 0. If you want to calculate the value of sigma, you can calculate, but you don't need to calculate here because this is 7 minus 7, so it is going to be 0. Okay. Now, what is the value of z less than 0?
0.5.
0.5. This value is known to us. Okay, otherwise it will be given in the question, but this is very general value that we should remember. So the answer will be 0.5. Okay, you can check. Okay, just coming in this range. Okay, so that's how you have to use those values given here. So in that particular question, we got fz. So this is what? This is standard CDF at point 0. Now in the other questions, when you solve, you will get some other values of fz. So you have to use that values in the questions. Okay.
Ma'am,
Yes.
ma'am, some question about the question number 2 and question number 4. Ma'am, what is the difference between them?
Question number 2 and question number
Question
4.
number 4.
Okay. Question number 4 is the number of accidents in a certain city is modeled by a Poisson random variable with an average rate of 9 accidents per day. Okay. Suppose that the number of accidents on different days are independent. So use the central limit theorem to find the probability that there will be more than 3,300 accidents in a certain year. So assume that there are 365 days in a year, then you have to calculate this probability.
Hmm.
Okay, so you want to know the difference between these two questions or how to solve this question?
Ma'am, my total confusion is, ma'am, when to find out the sample variance and when to not.
And here mu is given, so that's 9 because lambda is 9. So variance will be also 9.
Ma'am, sample variance sigma by n square root n.
No, no,
That one.
you don't need to use sample variance or those things. Simply here, this average is given for per day. Okay, on an average, 9 accidents are happening per day, and the probability that we have to calculate, okay, that is being asked for a year. Okay, you can see. So you can see that x1, xi is some random variable which is following Poisson random variable with parameter lambda, which is
Hmm.
lambda is 9 here. Okay, and you need to know the number of accidents the average number of accidents per year. Okay, so if you're calculating it for per year, then average will be 9 into 365, right?
Hmm.
So here, suppose you have to calculate the probability that x is greater than 3300. Okay, so you have to subtract the mean and divide by the standard deviation. So mean in that case will be 9 into 365. Okay, and similarly standard deviation. So for
Will be
Poisson,
same. Same will be 9 into 365.
yeah, 9 into 365. So
Hmm.
that will be your variance. So then you will take square root of it.
Ma'am, means in this question we don't have to deal with the average or sample size.
Sample size. No, why you need sample size here? You can solve it without that only. So the main idea is that you have to find the mean and the variance of that. Okay, that you can easily calculate because we know that for Poisson random variable, mean and variance both are lambda.
Hmm.
Okay, so that you can simply calculate. So this value, this 9 is given for per day, but we need for per year. Okay.
So, ma'am, expectation will be 9 into 365.
Yes. And variance will also be same.
Ma'am, so the question is asked about the sample, so that time we have to use sigma by root n, is it?
1 minute.
Ma'am, please solve it. We are getting confused.
Okay, 1 minute.
And
I think, ma'am, the main question here everybody is asking is when do you use sigma by root n? I think that is
Okay,
where
you
people are
are
getting stuck.
getting confused with these things because the thing is,
Yeah.
see, the central limit theorem is true for the summation of the random variables. Okay, so suppose you have x1, x2 up to xn. So these are IID random variables, okay, which are following some distribution. So the central limit theorem is true for the summation of these random variables, or you can say the sample mean. So this is the summation of those random variables, and if you talk about the mean, so this is x bar. Okay, so x bar will be x1 plus x2 plus xn divided by n. Okay, now whenever you are solving the question, you have to, whatever quantity you are using, you have to subtract the mean of that quantity and you have to divide by the standard deviation of that quantity only. Now it depends on the question whether it is asking you about the sum or it is asking you about the average. Okay, that depends on the question. Now if you are using s, okay, so let's calculate the expectation and variance of s first. So what will be the, okay, and the expectation of these xi value, okay, suppose it is mu, and the variance of xi, this is suppose sigma square. Okay, now what will be the expectation of s? This will be expectation of x1 plus x2 up to xn. So this is equal to expectation of x1 plus x2 like this. Okay, now the mean of x1, okay, expectation of x1 is mu. Similarly for x2 also this is mu, right? So for all the n variables, we have to add the mean, which is mu. So it will become n mu, right? So expectation of s is n mu. Similarly, we will find the variance of s. So variance of s, okay, that we can find like this. And these all are IID, so it will become the variance of x1 plus variance of x2 plus variance of up to xn. Now this is sigma square for all, right? So we have to add it n times, okay? So this becomes n sigma square, which is the variance of s. Now we need to divide by standard deviation. So standard deviation of s will be root n sigma. Okay, is this thing clear to everyone? So now here we can see that expectation of s is n mu and the standard deviation is root n sigma. Now we say that s minus the mean is n mu, right? And divide by the standard deviation, which is root n sigma. Okay, this follows normal 0, 1. Is this thing clear to everyone up to this point?
Yes.
Ma'am,
Okay.
we are finding expectation of x bar.
Yeah, we will do. Now we have to find the expectation and the standard deviation for x bar. Okay, so x bar is equal to, this was for s. When you are dealing with s, you have to do these things. Okay, now we have x bar, so x bar is this. Now calculate the expectation of x bar. So expectation of x bar is this one. So n is a constant, so we can write out of it. And this will become expectation of x1 plus expectation of x2 up to xn. Right? Now this is 1 by n and this is mu plus mu. Right? Now this quantity we have to add mu n times. So this will become n mu Now n
Intensely.
and n will be cancelled out. So expectation of x bar becomes mu. Okay. Now we have to calculate variance of x bar. So variance of x bar is, again, put the value of it first. Okay, now this is a constant and we are finding the variance, so this will become square of
1
it.
by n square.
Okay, now variance of x1 plus variance of x2. Okay, so this is 1 upon n square, and then again we have to add sigma square n times, right? Now you can see this will become n times sigma square. Okay, now it will become sigma square by n, right? One n will be cancelled out, right? Now what we have to do, we have to find the standard deviation of x bar. So this will simply be the square root of variance. So this will become sigma by root n. Okay. So now what we say, that x bar minus mean of x bar, which is mu, and standard deviation of x bar, which is sigma by root n. Okay. This follows normal 0, 1. Okay. This is the difference. Now is it clear when we use sigma
Ma'am,
root n, sigma
ma'am, this
n?
is for random variable. मतलब this is for sample mean.
Yeah, this is sample mean, this x bar.
No, ma'am, I am asking this formula is for sample mean.
Yeah, this x bar here is sample mean only.
मैं actually sometimes formula getting changed ना, वो एक बार y minus n mu by under root
See,
into.
formula is not getting changed. You just have to understand the difference. These two things we are using. Okay. So this S is the summation of the random variables, and this x bar is the mean. Okay, sorry, this is n mu.
Okay.
Okay. So those y and x are just for representation. So in those questions that we solved yesterday, y was the summation we were taking, right? Summation of the random variables. Okay. And if you are taking x bar, then you have to divide the mean, which is mu, and the standard deviation is sigma by root n. If you are taking the summation simply, then it will be n mu divided by sigma root n. Okay.
Okay.
So you have to remember those two things. Okay, when you are talking about the mean directly, or you are talking about the summation of the variables, like the total number of some quantity, something like that will be given. Okay.
Yes, ma'am. Also the graph part where we like plot the graphs of the distributions. I'm kind of having problem in that concept. Like activity 8.3 complete, I'm not able to
Yeah.
understand.
Yeah. So okay.
Ma'am, but previously, please solve the question number 4 of question activity 2.
Okay. Okay. One minute. Yeah. So, question again. I'm reading the question. So, the number of accident in a certain city is modeled by Poisson random variable with average rate 9 accidents per day. Okay. So this is given for per day. Now in the question, it is saying that suppose the number of accidents on different days are independent. Okay. So use the central limit theorem to identify to find the probability that there will be more than 3300 accidents in a certain year, and assuming that there are 365 days in a year. Okay, so this xi, okay, this is following Poisson distribution with parameter lambda equals to 9. Okay, so for xi, yeah, so for xi the mean is equal to 9, right? And the variance is also 9. Now this average number of accidents per day okay, this is 9, and if we want to calculate average number of accidents per year, so per year it will be 9 into 365. Okay, so this will be equal to
3285.
85. Okay, now we are asked, it is asked that there will be more than 3300 accidents in a certain year. So certain year, suppose y is a variable which is representing the number of accidents per year. Okay, so now x was representing the number of accidents per day. Okay, y is also a variable, but it is representing number of accidents per year. Okay, what we have to find here, we have to find that y is greater than 3300, right? Is this thing clear to everyone, this part?
Yes, ma'am.
Okay, so x was for one day, but we have to calculate for per year. So actually we are asked that y is
We
greater
have
than,
to
yeah,
add all.
yeah. So now the objective is to find the expectation or the mean of this y and the standard deviation of y. Okay, now tell me what will be the mean of y.
9.
Why 9?
3285.
3285.
Yeah, it will be 3285. Okay, that we have calculated here. So average number of accident per year is 9 into 365, which is 3285. So we have to subtract the mean, which is 3285. Similarly, what will be the variance?
3285.
3285 only, right?
Yeah.
Okay, because for y it will be the lambda will be 3285 only. Okay, now we have to divide by square root of it. Square root of variance. Now this quantity has become z, right? Greater than this. Now solve this part. So this will become 0.2617, right?
And the probability of this is given.
Yeah.
So the probability will be 1 minus probability of z less than.
So we are given that fz value of 0.2617 is 0.603. Okay. Now this thing, we can write it as 1 minus fz at 0.2617, right? Is it clear to everyone?
Yes, ma'am.
Okay. Now just put the value.
Hello, ma'am. I have a question. So for most of the questions, this particular fz of some value is like always given. But for a few graded assignment questions, these are not given. So I found three graded assignment questions for which the fz value was not given. So I was not sure how to enter the value there.
Okay, if it's not given, then you can use the normal table. If you search on Google, you can find those. You can find the
Uh,
table, and from table you can see. But the
okay.
values will be given, I think,
For the
No,
graded
no, it's
assignment,
not given.
not given.
yes, ma'am. For the graded assignment, it was not given.
Okay. Okay, then you can see by searching the normal table, standard normal table, and you can find those values. Okay.
Okay. Standard normal table. Okay. Thank you.
Yeah. So if it is z, then it is a standard normal variable,
Yeah.
normal 0, comma 1. So standard normal table you can find easily on the Google, and you can see the values. Yes. Any other question?
Yes, ma'am. In the graph, ma'am. Activity third.
Yeah. Okay. So those things are not very in detail. Okay, if you have seen the lecture, it's there. Plotting of the graph, it's not there in your syllabus, but you can see the graph of these things. Yeah, so if you look at this lecture, you can see how the graph looks like for different distributions. Okay,
So we have to remember these.
so don't worry about these kind of questions. So it will not be asked in the exam. But
Okay, ma'am.
okay, for activity 8.3, so you can see. So for the first question, the some tricks you can use that beta distribution. The range of beta distribution is from 0 to 1. Okay, so the graph will be lying between 0 to 1. So in the first graph, you can see it is lying between 0 to 1. So you
Okay,
can
ma'am.
see that it will be beta. And normal distribution, we know that it is a symmetric bell-shaped curve, right?
Yes, ma'am.
And for exponential, the range of exponential is that x is greater than 0. So from 0 to infinity, you can get any value on the x-axis. Okay, and then we have gamma distribution. So for gamma also, the range is like x is greater than 0. So you can find those values. And for Cauchy and for normal distribution, the range is minus infinity to plus infinity. So for Cauchy and for normal, the graph is similar to the normal distribution, this bell-shaped curve. Okay, but the thing is, it will not be same for all the distribution. So it's not in very detail here, so don't worry about those things. But yeah, these are some tricks that you can use. Exponential distribution is like this, something like this. But this line changes according to the parameter. It's not always same. Okay.
Okay, ma'am.
Okay. Anything else?
Ma'am,
Yes.
ma'am, question number 1 of practice assignment 8.
Okay. So again, this is from like x divided by y follows some certain distribution.
Cauchy.
Yeah. So from there you can find. So the thing is, if x and y are following IID normal distribution, okay, then x divided by y follows Cauchy distribution. And for Cauchy distribution, mean is not defined. Okay, so the answer will be undefined.
Why is it Cauchy? Why is it Cauchy distribution? Because it's normal by normal, or
Yeah, this is a property actually. So if you have two random variables, okay, which are IID normal, okay, which means that both should be independent of each other, and they both should be following normal 0 comma sigma square distribution. Okay,
okay.
then the ratio of these two variables, so we have x and y here, so x divided by y, okay, this follows Cauchy distribution. Okay, and for Cauchy distribution, the mean is undefined.
Okay.
Yes, anything else?
Ma'am, in CLT, we were talking about the sample mean, the formula, right? So,
Mm.
could you please give the example for that question and just solve that, ma'am? Because we solved the Poisson distribution of accident case, which is used for a normal thing. Normal sum we used for what is that called? S minus nu divided by that one. So, for a sample mean, can we use any other formula for any other question, ma'am?
Yes, we have solved those questions. Yesterday also we have solved the questions where we have done it for mean and we have done it for the sum also.
Okay, so if the question is giving explicitly that the sample mean is given, right?
Hmm.
Okay.
No, what you're asking, sample mean is given.
The question will be explicitly given about the sample mean of random variable, right? Because the last sum we solved is not given about the sample mean and all.
Oh, 1 minute.
8.2, it's fourth question. Yeah. Yeah. Over there, it's not given any sample mean thing like.
Yeah, these things are not given. You have to read the question and you have to decide.
That's
Okay,
what.
so okay, so read this question. So here in this question, it is asked, find the probability that a random sample of 25 bulbs will
Uh,
have an average life. So
yeah.
here you can see that it is asking about the average life is less than 615 hours.
Yeah.
So you have to find the probability that x bar is less than 615.
Okay. Okay. Okay.
Okay.
To
So we
calculate.
can standardize here by using this x bar minus mu by sigma by root n, right? Because
Yeah.
n is given.
Yes. Yes. Yes.
Okay. Okay. No, got it. Yeah.
But ma'am, sample mean and distribution mean both are same, right?
Sample mean distribution. Like what do you want to
Sample
know?
mean and the distribution mean, they both will give the same answer, right?
You're asking about the sum, right? Not the distribution mean, I think.
No, no, I am asking about the mean, sample
Hmm.
mean and distribution mean in common. They both will
In,
give the same answer, right?
in any increase, that's the case.
See, sample mean, the thing is, you have a population which follows some distribution, and if you take a large sample from that population, then the distribution of sample mean tends to follow normal distribution. So you are saying distribution mean. So what distribution mean? Like
Ma'am, it's
you
the
have some
n
Sum of
population.
sample.
random variables upon n.
Yeah.
See, 1 minute. So you have some variables x1, x2. Okay. So these are IID variables, and they might follow any distribution. Okay, and then you are taking a large sample from this population, and you are saying that we have variables. Suppose some of these variable. Okay, or you are saying that the sample mean. Okay, so these sum or sample mean, if you take it for large sample, then it tends to follow normal distribution. So when either you use this thing or this thing, both will give you the same answer if you are approximating any probability. Suppose x bar is given, then you can convert it like s by n. Okay, and you can solve accordingly.
See,
Ma'am,
sometimes the mean is actually is equal to the original the population mean, right? So because the sample sizes get increased.
Yes, that's what I was saying.
So you are
Yes.
saying that the distribution of sample mean will tend to follow population mean.
Yeah, yeah.
No, no, it's not like that. We are using central limit theorem, which says that the population distribution can be anything. Maybe it's Poisson, or maybe it's exponential or gamma. Like it can be any distribution and or any non-standard distribution also, which we don't know. But if you take the large sample from it, then the sample mean, okay, this is a sample mean, and the distribution of this sample mean will tend to follow normal
Normal
distribution.
distribution. So
Okay,
that mean is zero. You are saying, right?
yeah, that follows normal distribution. Yeah, standard normal distribution, yeah, with 0 and 1.
Okay, okay. Then the it tends to the mean tends to zero. Is it correct?
For sample mean, yes.
Yes, yes. Okay, now got it. Yeah.
Ma'am,
Yes.
ma'am, ma'am, CLT will always follow normal distribution, na?
Yeah, it is for normal distribution for sample mean,
Oh,
or some of the IID variables.
ma'am, these properties of gamma, Cauchy, and beta will be given in the exam, right? Means mean, variance, and everything.
Yeah, if it is asked, then it will be given. Otherwise, most probably questions will not come from these distributions. Okay, these are just for the introduction parts. They are not in much detail.
Ma'am, it was given in weekly note that if we increase the and then sample mean will tend to the actual actual mean, then how that comes? मतलब distribution mean.
Okay, I'm not sure about what you're asking. I'll see and we'll let you know. Okay, anything else?
Ma'am, in practice assignment, second question, I have some doubt.
Please.
The population mean. This is simply some na population mean it was written.
So, our study shows that average daily sleeping hours of teenagers is 10 hours, with standard deviation of 2 hours in a day. So, a sample of 100 teenagers is collected. What will be the probability that mean of sleep hours of 100 teenagers is at least 0.4 hours away from the population mean? So, if you are saying that the average for this sample, okay, which we have taken, sample of 100 teenagers. So, if you are representing it with x bar, then this x bar, and suppose the population mean is mu. So population mean is represented by mu. Okay, then it is saying that the average is 0.4 hours away from the population mean. So this difference x bar minus mu, okay, this is less than 0.4. Okay, this probability you have to calculate. Okay,
Okay, ma'am.
Anything else?
Ma'am, in
Ma'am, you
fourth question, ma'am, in fourth question, we just divide expectation of x by expectation of x plus expectation of y. In fourth question.
you can use beta distribution for this.
Yeah. So here we are given two variables x and y which are following gamma distribution. Okay, and they are independent, and it is asked what will be the expected value of x divided by x plus y. Now again we have to use the property that if you have two variables x and y which are following gamma distribution, okay, then x upon x plus y follows beta distribution.
Okay.
Okay, and how will you decide the parameters? So the general thing is if x follows gamma with parameters, suppose alpha comma 1 by theta, okay, and y follows gamma with beta comma 1 by theta, okay. In that case, x upon x plus y, this follows beta with parameter alpha comma beta, okay. And now
But
for
ma'am,
beta distribution,
parameter of gamma is alpha comma beta, na?
see, these are for notation. For gamma also alpha and beta are there, but values will be different. That doesn't
Okay.
affect. Okay, now you have to find the expected value of this. So expected value of a beta distribution, beta random variable we are asking. So if you have a random variable which is following beta alpha comma beta, okay, then mean is alpha upon alpha plus beta. Okay. So by using this property, you just put the values of alpha and beta and then you can find the expected value. Okay, so here you
Okay.
can see alpha will be 2, x is following gamma 2 comma 1 by 2. So alpha
Yes,
is
ma'am.
2.
2 by 7. 2 by 7.
Yeah.
Ma'am,
Hmm.
ma'am, will you please share some thing like how can we proceed in exam because time is little less.
See, the thing is, if you practice more and more questions,
Yes,
okay, then when you see the question, it will not look very new to you. And you will know that how you solve the question and you can easily solve it. So the practice is the most important thing.
actually last time I was trying for the l- big questions and I lost the question that I knew the best.
So okay, so whenever you are solving the question, you just like read the question paper, okay, go through it once and then solve those questions which you know that you can solve 100%. So you will get some confidence. And then
Yes,
solve those questions which might take some more much time than the other questions, okay?
yes, ma'am.
Solve them at last.
Okay.
Give them some time, read it carefully, and then start solving the question.
Ma'am, you said PYQ is not just enough, so what to do?
Not enough means we are not saying that it's not enough. You need to solve it. But the thing, if you're expecting that you will get the same question from PYQ, then it's not going to be like that. So you practice PYQ, it's going to be helpful. That's okay. But the thing is, you need to understand the concept also. If you're only solving the PYQ question and you're expecting that you will get the similar question and you can solve that, then this will not help. So you
But ma'am,
understand the concept first, okay? You understand the concept first and then try to solve the questions based on that topic.
ma'am,
Otherwise,
the thing is, even the mock paper which you guys gave is not like matching the paper in the quiz one. That that's the thing which like was a little problematic for me.
see, if you have solved the questions of GA activity and the previous questions, not like that the question paper was very different from that. But the thing
Yes,
is, you
ma'am.
have to solve it on your own. If you are just submitting the GA by using the chat GPT and you are not solving the question on your own, then it will not be helpful for you because you are
Ye-
actually not practicing the questions.
Yes, ma'am. Ma'am, the questions were solvable in the quiz one. The questions were solvable, but yeah, the deciphering the question was harder. Like finding the information which was important from the question because majorly were application based.
Ma'am, actually, in one question, we have to find around 2 to 3 informations. That's why.
No, no, it's not like that. Whatever the question is asked, it will be the marks will also be according to that. Like if any question is 3 marks, then you have to do the calculation according to 3 marks. It will have some. It will involve some calculation in it.
Ma'am, but there was a very different question in quiz, ma'am. I thought memory list property was only for the geometric distribution, but there was a question of exponential distribution also.
Yep,
Yeah, so it's
the
there in the
property is
syllabus.
there. Yeah, it is there in the syllabus. Sir.
It's there in the syllabus.
But yeah,
That's
but
why the
this
see.
type of question should give in the activity or practice or graded assignment. So we need more question to solve. Then this kind of questions in graded practice and activities, we need extra questions
Yes,
to
ma'am. The
understand.
mocks, yeah, and
Yeah,
the
so
mocks too should be like
more question,
more
okay,
aligned,
50
more
question or
aligned
60
to the
question like
paper.
that.
The
Give more
mock
and more
was
questions so
completely different.
Ma'am, like in mocks,
See,
there should be
if
like
you are
some
expecting that you will
related
get very
questions.
similar questions to the like quizzes, then it's not going to be like that. We cannot
Yes,
give you the
ma'am.
same similar question.
Yes, ma'am. We
In the
agree,
exam, you
but
will definitely get new kind of questions.
yes, ma'am.
So
We
you
agree
have, yeah. So you
according
have
that point.
to
But
prepare.
since the previous year questions and even the mock was like having a simple pattern, so we thought like the quiz will also be simple. So that like
Ma'am,
Yeah.
like
kind
So
of
in
now,
mocks, ma'am, in mocks, there will be some similarity with quizzes. It will be really helpful.
More than that, actually, I do agree that we have to solve according to the whatever we understand from the syllabus. I agree that, but actually, what our practice is usually we do all the activity practice and graded and PYQs. So we'll have some confidence. Okay, we can see the question. Okay, I've seen the question. Okay, like that. So when the time constraints on 1 hour, so on that particular time, so take it of all the information what we gathered from the learning. So again, I'm the so constraint of the time, so it's not enough for me actually. So which is contradicting. So I we request like more and more questions if you are giving in the activity as graded, add more questions like. Even in the JEE exam, people actually they are solving 10,000 sums actually for that multiples, but we don't have that kind of things to get more sums actually. So if you could have like a different pattern of questions, so that so at one point even examiner whoever take printing the whoever taking the question pattern, right, like you instructors and also they don't have other pattern than that, so that will come across all the pattern of that.
No, no. I think we have enough activities to do.
okay,
No, no,
1 minute. Okay, anyone has any doubt from week 8? No one has any doubt from week 8? Otherwise, I'll stop streaming. After that, you can discuss.
Yes, ma'am. Doubt in tutorial 2.
Which question?
Ma'am, can you open?
For tutorial, also solutions are given. Did you try to solve those first?
yes, ma'am. Tutorials are done.
Which question? Question number?
Ma'am, what?
Yeah, question number
Ma'am, one.
1. Okay. Okay, so x1, x2 up to xn id x is given, and y is the summation of those variables. Distribution of x is given. Then you have to use the CLT to approximate this. Again, you should know the variance in expectation of y. Okay, and for calculating the expectation and the variance or standard deviation of y, you need to find the variance and expectation of x, right? So first you will calculate the expectation of x and variance. So for variance, you need to calculate expectation of x square. Okay, that you can do because PMF is given. Okay, so this is the expectation and variance of x. Now we know that y is what? The summation of those variables. So if you remember the formula, it will be y minus n mu divided by root n sigma, right? So mean is
For
0. Okay, so expectation of x is 0. If you add it n times, then also it will be 0. So this is actually y minus 0 divided by root n sigma. So root n, and this is the sigma standard deviation.
yes.
Okay, now you can see that this will follow standard normal distribution. Okay, the same thing. So here we have delta n. So here also you have to subtract the mean and divide by standard deviation because you have to balance the equation. So whatever changes you are doing at this side, you have to do it here at the right hand side also. So it will be minus 0 divided by root 33n by 5. And when you solve it, this will become z. And this is greater than delta n and this value if you solve it. And this will be converted into CDF of standard normal.
मैम ये वाला पॉइंट मुझे नहीं समझ में आ रहा है कि y इज ग्रेटर देन समथिंग है तो 1 माइनस क्यों आ जाता है?
Okay, this is the property. The property is that if probability of y is greater than some value, suppose c, then you can write it like this also: 1 minus probability y is less than or equal to c. These both the things are same. So if you represent it on the real line, so suppose this value is c. This is the point which is c. Okay. Now y is greater than c, which means it is covering this area, this region. Okay. Now according to this line, it is 1 minus probability y is less than or equal to c. So 1 means the entire region, okay, that you have, and 1 minus, which means y is less than or equal to c, will be this.
Yeah.
So from entire this line, if you subtract this red region, you will be left with this one, right?
Yeah.
That's how these two are same. These two are equal to each other. Okay, why we are converting it like this? Because we know that this probability y is less than or equal to c. This is nothing but the CDF. Okay, this is CDF. If it is y, then it will be y. If it is z, then it will be z. Okay, and then we know the values of standard normal, the CDF of standard normal. So those values will be given to you in the question, so you can use them.
Okay.
Anything else from week 8?
No, ma'am. I'm just that those questions like in which we have to find the moment, right?